All right, I calculated acceleration and it was 1.42 meters per second squared. So let's try it again. Let's all go to the back page and let's try number 7. So on number 7, we want to calculate, it's basically the same problem. We want to calculate the block's acceleration down the ramp. So we know it's accelerating this way. We know we have force normal. We know we have force friction and force weight. I'm going to make this my x-axis, the ramp, and I'm going to make this the y. I basically do it by laying the ramp down, just crushing it 35 degrees. So it turns out then that my, can y'all see that? That my force normal is up, my force friction, and my force weight is off this way, and he goes off at 35 degrees because I laid it down 35, and that made him swing out. I rotated everybody 35 degrees. Okay, so now let's label it. What do we got? We've got force friction is mu Fn, which mu 0.32, coefficient of friction. We know force weight is mass times gravity. Our mass is 45. And I multiply that out, that comes to be 441.45. All right. So let's find the x and y component of force weight. I need force weight x and I need force weight y. This time, this one will be r sine theta and this will be r cosine theta. Again, you want to know this side. It is opposite hypotenuse. Remember, sine is opposite hypotenuse. This side of the right triangle is adjacent to the angle hypotenuse. Isn't that adjacent hypotenuse? So if I do r cosine and r sine, turns out that this is 253.21, and this one over here is 361.61. I think it's 61. Okay. It's accelerating down the ramp, so there is a force on it. Newton said you have to be accelerating. Now, is the force in the x, the y, or what? Well, it's accelerating, which is now this way, because we laid it down. So I can say all the forces in the x-plane have to be ma. I can rearrange it. I can put my mass down here, and now I can say, who are my forces in the x-plane? Force, weight, x minus force, friction. So I just filled in the numbers, just like before. The hardest thing in this problem is understanding that you're making this the x-axis. I say it's easier to look at it like you're laying the ramp down. So again, I come here and I like, oh man, I'd be finished, but oh dadgummit, if I only had force normal. Well, what kind of force is force normal? He's a y guy. So let's go over to the y's. Keep the x and y separate. All the forces in the y equal ma or 0. Is it accelerating in this plane now? No. 0. Who are my forces that go up and down? Force normal minus force weight. Can I say force weight equals force normal? 361, 61 equals force normal. I take that, I plug it in here, and I get an acceleration of everybody should calculate this, but I get an acceleration of 3.05. Okay, there are two inclined planes. So let's go back and do one more problem. And that's the one right here, number 4. So we've got the mass. We've got a force applied at a certain angle. We have coefficient of friction. So let's first off draw our free body diagram. That's my block. Okay, I have force normal and I have force weight. That's easy. But I have force applied at an angle. So here's force applied. Do you see I have to find force applied X and I have to find force applied Y. Sometimes an easier way to look at this or to do it is you could draw the free body diagram like this. Force normal, force weight, and then I draw force applied out this way. Why? Because normally we have, it's just like it just went through. It's still the same force, I'm just showing it on the other side. This is the 28 degrees. See? So instead of being on this side, I just took it all the way over on this side. We always have force applied on this side anyway. So I need to find force applied X and force applied Y. Same thing here. I'm going to continue on this one because I have more room. Okay, how do I find force applied X? We know that the force applied is 330 newtons. This side is adjacent hypotenuse. So this is cosine, r cosine theta. So this one would be r cosine theta. And that turns out to be 291.4. And this one is r sine theta. It is opposite hypotenuse, and that turns out to be 330 sine 28. And I get for that one 154.9. All right, there's my free body diagram. Find the acceleration. So we know that the block is accelerating this way. Oh, I forgot one force. Sorry about that. I've got force friction. She's pushing on it, and it's accelerating that way. So all the forces in the X equal ma. Therefore, all the forces in the Y cancel out and equal 0. Acceleration equals who? My forces in the X. 291.4 minus mu Fn. I forgot to write that on here. 0.17 Fn is how you find force friction. Divided by mass. 33. There it is. Same thing we've been doing. I get to force normal. Dadgummit, if I only had force normal. Where is force normal? He's a Y guy. So let's go get them in the y equations. Don't I have force normal minus force weight? I forgot to calculate force weight, which was 33 times 9.81, which turned out to be 323.73. All right, so I'm rearranging it. Force weight equals force normal. Force weight, 323.73 equals force normal. Plug that in, and the acceleration I get is 6.36 meters per second squared. It's pretty basic. Same old thing. Which side is it accelerating on, or is it accelerating at all? But you always work your way down, and you got to go over to the y to find something. So I want you to finish this packet, especially what's on the first page, and we will discuss anything when I return. Thank you.